Thank you very much for the introduction, and thank you to the organizers for giving me the opportunity to speak here. So I'm a scientific software developer at Hypera Software in the UK, and I'm the lead developer of Glue. So Glue is a multidisciplinary Python package for multidimensional and linked data exploration. And the kind of linked data exploration, I'm going to explain a little bit more in detail in this talk what we mean by that. So the motivations for building Glue were the following. So the first is that data are highly dimensional these days. So I'm not just talking about the fact that you can have images and cubes and hypercubes, but also that generically if you have a table of data, then you have as many dimensions as columns. And when you have many columns, you need to be able to explore those interactively to look for trends and so on in the data. Now, the other thing is that a lot of the time, data is not simple. It's heterogeneous. You have a mix of different kinds of data. It's very rare for researchers to basically have one single file that they have everything about a project in, and then be able to analyze that file. In reality, things are a lot messier. People have, images, multiple images, maybe gridded on in different grids, and then also, tables of data and so on. And so the idea is we need to be able to link all these data sets together and visually explore those at the same time. The third motivation is that a lot of the time, scientists are interested in a subset of the data. So, there's cases, of course, where you're interested in the whole data set, but a lot of the time, you're actually interested in exploring, a very large data set and drilling down on very interesting subsets, maybe unusual subsets of data. So we need ways of constructing and combining selections of data in this high-dimensional space across multiple files. So that's the motivation for Glue. Glue is a Python package written in, I should say it's a Python package. It's also a library. It's an application. So there's kind of different aspects of Glue. It has a Qt interface, which we first started developing in 2011. So it's reasonably mature now. And since last year, we've been starting work on a Jupyter interface to Glue, which I'll also talk about in this talk. So I'm just going to show an example of a Glue session, just so you have an idea of what it does, what it looks like. This is the main Glue interface. On the top left over here, you basically have the area where you'll see data sets and subsets. This main area in the middle is where you'll make visualizations, and the bit on the left is where you'll have options that control aspects of the visualizations. So I'm going to load in a data file, which is basically it's transmissions from planes in the Boston area over about a month using ADS-B messages. And so you can drag a data set onto the canvas and select what kind of visualization you want to make. This is making a scatter plot of the positions of the planes in X and Y, just relative to Boston Airport. And you can start to see, all the kind of flight paths for the planes over time. And there's also a kind of general scatter of points. So you can make, of course, multiple visualizations. So you can drag the data and then say, okay, now I want to make a plot of, in this case, it's going to be altitude of the plane versus heading, so the direction of the plane as an angle between 0 and 360 degrees. And you start to see interesting trends in the data already. And then on the bottom right, I'm just going to make a 1D histogram of the data. So where we'll show the vertical rate, which is the speed at which the planes are going up or down. So the idea here is there's a single data set for now, but we have multiple visualizations which are linked together automatically because they're showing the same data. And so these blue tools on the top of each viewer are selection tools. So you can go and select some points. We're just going to do a rectangular selection here to show some of the points. We automatically see those highlighted in the other visualizations. This is kind of like, you can think of it as a dashboard, but that you constructed very kind of interactively. And then, of course, we can make selections in other visualizations and, again, see those propagate to the other ones. So finally, I'm going to select planes that are descending currently and see where those are in the other visualizations. Of course, you often will want to explore maybe multiple selections, multiple kinds of subsets. And so up here, you can actually select that you want to create a new subset, not just replace the existing one. And we can go to the bottom right here, and then essentially select all the planes that are going up currently, and then see those highlighted in blue in the other visualizations. Okay, so a lot of the time, because it's a high-dimensional space, you might want to combine selections from different, essentially different visualizations, so different dimensions. So what happened here is that I changed the mode to be a kind of AND mode, which means basically doing the intersection of the selections that I've just made with the previous subset. So it's now constraining the subset rather than just replacing it every time. So once you have your subset, you can choose to export it if you want. So in this case, we can just select which subset to export and export it to a CSV file. So of course, I mean, you can continue to do things with the subset in Glue, but this is just an easy way to get the data out of it. Now, there's other kinds of visualizations in Glue, and just since we're running out of space, I've just made a new tab. I'm going to make a 3D scatter plot now. To try and show, one of the subsets in real 3D space, so X, Y, and altitude. And so I'm going to show this mention this a little bit later, but you can also build, any kind of custom visualizations into Glue, and you're not limited to just the kinds that you see there. Okay, so I'm selecting the different attributes to show in this viewer. And I've chosen to show just the red subset, so these were planes that are currently descending. And so this is now showing the 3D distribution of those points. You can kind of see, it's going to turn in a minute. There's basically planes that are at high altitude, and those are ones which have just started to descend, but they're probably going to land at another airport. And then all the points at the bottom are the ones that are landing actually at Boston Airport. Now, in the 3D viewer, you can also make selections, and so the nice thing is you can make selections from different points of view and kind of combine those. So remember, we're in the AND mode for selection, which means we're going to combine the selection we just made with the previous one, which means we're selecting just those red points, and then we can continue to clean up that selection by turning the data and then making a selection from a different point of view. And then, of course, this selection has propagated to the other viewers, so we can go and look at, the scatter plot, 2D scatter plots, and see where those points are. Another kind of useful viewer is actually just a simple table viewer. Sometimes you just want to see the data values and not just plot them. So we have a table viewer when you can choose to show just a particular subset that you're interested in. So then now, if you want, you can go and look at the data in detail. So you don't have to export it to actually look at the values. Okay, so this is just a single data set, but the power of Glue is being able to glue together multiple data sets. So I'm going to open up a satellite image, basically of eastern Massachusetts, and I can now drag that data set again onto the canvas and make a 2D image plot. So the nice thing about this image viewer is it will only access data that's actually really needed. So if you have a very large data set and you're memory mapping it so that you're not actually loading up on the data, the image viewer will just access the parts of the data that are needed. You have all the kind of features you would expect from an image viewer, so you can change the color map, the contrast and bias, and you can also, as I'll show in a minute, you can show multiple images at the same time. That's Boston Airport with the 3 runways. And what we can do now is, so the thing is that Glue doesn't know that this data set is related to the catalog. So we open up this link editor, and you can see there's 2 data sets. They're not linked yet, and you can select which attributes to link between the data. Now, in this case, the kind of link is a very simple link. It's just saying this is the same as this, but you can actually use, and I'm going to show just in a second, there's a whole bunch of other kinds of links, and you can define your own kinds of non-linear links. So any Python function that transforms some set of values to another set of values is a valid function to construct a link with. So then now we've actually linked the data sets, we can easily take the data from, for example, the red subset and then overlay that on top of the image, see where those points are. And then, if we make a selection in the other visualizations, then, the selection in the image viewer will now update. So now this is all the planes again that are descending, some of them towards the airport, some of them towards other airports. And you can see actually that the data, the plane trajectory is actually aligned nicely with the runways. Now, because Glue is built in Python, it means that we have a built-in IPython terminal, and anything that you see, you can interact with also from Python. And so in this case, I'm showing that you can access the data collection, which has 2 data sets. We can look at the details of one of the data sets and see all the attributes in that data. And then you can do any kind of analysis you want. So I'm just going to use the counter class to find what the most common call sign is for an aircraft. So the call sign being like the flight number or the aircraft number. And then basically looking for the 5 most common ones. The first one is just 00, which means that it's just, I think there's no valid code. So we can take the second one and we can now construct a subset programmatically. So we can make a selection programmatically. Using just this flight code, so we can look at just the points that are for that aircraft in particular. So that's the aircraft that has the most points. And so you can see, I mean, the API is all described in detail in the documentation, how to do this, but you can actually see now the points actually have an interesting pattern, and that's because actually it's not a plane, it's a helicopter. If you search for that flight code online, you find it's a helicopter, I think, and I mean, that basically explains why there's so many points, because it's just kind of hovering around the city, and so it has a lot more points than planes that just go through the airspace. Okay, so this is just an example. This was just to give you a sense of what Glue can do. So you can take multiple data sets, link them together, make selections, multiple selections, combine selections together, and do everything programmatically. So I'm going to mention a couple of, if you're already familiar with Glue, I'm going to mention a couple of features that we've added in the last year or so, which I think are really important. The first one is that a lot of the time when you're in a certain domain and you have your data sets, there's certain ways of linking the data that can be standardized, and you can basically write a Python function that says how to link data sets. So we have now a framework for doing this, for essentially defining auto-linking functions. And we've implemented it for some kinds of data sets already. And the other thing is that in the image viewer and in the 3D volume rendering, which I've not shown yet, you can basically show multiple data sets together that are on different grids. So in this example, I'm going to load up, this is just an astronomy example because astronomy images are very pretty. So it loads up 5 different data sets, and you can see it says, I've identified links between these data sets, and you can see the whole network of links it's suggesting. So you can go and, if you want, look in detail at some of the links, you can choose to apply those, and you're done. The data's now linked. So what you can do is basically take the data sets and start showing them together at in the image viewer. So I'm going to go really fast just to show essentially constructing, in this case, a 4-color image. So it's assigning each image to a different color, so it's different wavelengths are different colors. And then basically what's happening is that on the fly, as you move around, it's basically, so these images are on different grids, okay? And so as you move around, it keeps kind of reprojecting the images onto the grid of essentially the display pixels. And again, this is very efficient. If you have very large images, it'll still work fine. You can do this with 100 gigabyte images in principle if you want, and as long as it can go and access just the parts of the data it needs. Another important feature that we've been working on is that we wanted to be able to support large data sets that are not necessarily local, and data sets that are not necessarily just kind of regularly gridded data. So for this, basically what we've done is we've defined an API basically for data objects that they have to present in order to be able to be used in Glue. But Glue then doesn't need to care about the details of how the data are stored. It just needs to, the data object needs to be able to return, for example, a histogram, n-dimensional histograms, or statistics like minimum, maximum, mean, and so on. And then Glue can just use that without caring about how the data are stored. So this specific example is I actually just a few days ago I spun up on EC2 an instance where I put this is the famous New York taxi data set for I think for 1 year. So it has 146 million rows, and I put it on an EC2 instance that's not particularly powerful, but just to show that it's remote. And then we're using a library called Vex to kind of do the interfacing with the server. And as I pan around, it's basically on the fly recomputing 2D histograms, density maps of the data. And there's 146 million points, but it's fine. It's not too slow. And you can also then, I'll show in a second, make selections. You can see the plot on the right shows the trip distance versus the fare amount. And there's, if you've seen this data set before, you know about this, but there's this spike basically in the data in the middle, which is around $52, which I think is the flat fare to get from the airport to downtown Manhattan. So we can select that, and you'll see that. So currently the airport's not in view, but so in a second, so the selection is made. It's all done kind of in real time. It asks the server to return now density maps applying that selection. And you can see that as we pan across, the subset renormalizes, and most of the red points are at the airport. So that's the pickup longitude and latitude. So the idea here is that, because Glue doesn't care about how the data are stored, you could in principle have arbitrarily large data sets that are remote, that have a whole computer cluster doing computations, as long as they can return what Glue needs at the end of the day. All right. So this also works with, I'm not going to show here, but we have proof of concept of working with the YT package, which can access simulation data. And in that case, it's not so much that the data is remote, it's that it's got kind of nested grids and it's not very regular. But as long as it can return essentially fixed resolution buffers, image slices through the data, we can use it in Glue. Now, one of the main features of Glue is it's very highly customizable and extensible. So many of the things in Glue can be customized, and we wanted to make it really easy for researchers to do this. Okay, we don't want people to have to be kind of advanced developers to customize things. So this is an example just of how you would implement a very simple data loader for JPEG images, right? I mean, we can actually read JPEG images, but if you couldn't, this is how you would write the code. So it's very simple. You have to write a 2-line function and then another 1-line function which just identifies if the file is a JPEG file. There's much better ways of figuring out if a file is a JPEG file than by doing this, but it's just an example. Another thing you can do is create custom link functions, for example. And again, this is an extremely simple one, but you could have arbitrarily complex linking logic, essentially, to link attributes between different data sets. So the idea is scientists can basically just write simple code like that, put in a file called config.py in the current working directory, launch Glue, and then Glue will automatically recognize those things. Now, there's better ways to do that. You can, if you want to actually distribute it to other people, then you can build a plugin package, which all it is just a simple Python package which has some of these functions in it. But of course, some of the plugins can be more complex than what you would just put in a single file. So just to give some examples, there's the Glue geospatial plugin, which basically currently helps us read in things like geotiff files. So the satellite image I showed before was read in using that plugin. Glue medical, which can read DICOM files, and we're working on support for Nifty and NERD formats. Now, these plugins are very kind of early stages of development, and what we really want is to actually find people, like you, who are domain experts in certain domains to help maintain these packages and really drive the development of the plugins. And the good thing about the plugins is there's a very well-defined, API for doing things. In Glue, you don't need to actually ever look at the main Glue code. You just the plugins are actually much simpler in terms of a code base. So if you want to get involved in the project, these are great places to get involved. Now, the plugins are not just about what kinds of files to read and linking. You can also create custom visualizations. So we have an interface to the Worldwide Telescope package, which is basically, it's like a kind of online planetarium application, which I'll show in a second. And we also have Glue Plotly, which is, it's again, very kind of early stage plugin to be able to export some of the plots to Plotly. So Worldwide Telescope, despite the name, actually also can show, it's not just space, you can show the Earth. This is actually, so it's a 3D rendering of the Earth. It's actually, you can go down to street level if you zoom in. I'm not going to show it there, but I've shown data for all the earthquakes in, I think, 2010. And then I can, again, make selections, in other plots, so in this case magnitude and depth, pick the strong, the earthquakes that are the deepest, and then see those appear in red on the left. And you can actually see, as you turn around the kind of parallax, you can see that these points are deeper. So it's really showing a full 3D rendering of the positions. So the other thing that Worldwide Telescope can do, of course, is space. So this is an example of, so we're looking at the sun. We're going to zoom out a little bit. We'll see the solar system. The data set I have here is a data set of all known stars that have planets around them. And so basically, actually, these points are from a particular survey. If you're an astronomer, you'll probably recognize it. And the idea is that I can actually show these points in 3D space. So as I zoom out, I'm going to get to the level of, this is just a model image of the galaxy, but it's basically, you can see on these points here, every single white point is a star that has at least one known planet around it. So there's a lot of them, there's 4,000 of them so far. And you can kind of see it actually the biases of the survey. The cone is basically a survey called Kepler, which really found a lot of stars with planets along a certain direction. So actually there's way more. And if you make a selection, then you see again the points in the other viewer. So the point of this is to show you that you can make custom visualizations. This is just a plugin package. We didn't have to modify any of Glue to do this. We just essentially, it's actually a web page running inside that window with the online planetarium, and we just interact through a JavaScript API. Okay, I promised also to show the Glue Plotly plugin. So this is showing, first I'm going to show something else, which is that if you have a plot, like a 2D scatter plot, you can actually go and when you save, so of course you can save, I'm just going to pause this for a second, but you can save as a PNG file, PDF, and so on, because we're just using matplotlib in this case. But when you save, you can also, there's other options. You can save as a Python script, or you can save to Plotly. So I'm just going to demonstrate, I'm going to demonstrate exporting to a Python script first. So you can take the plot, save to a Python script, and when I say Python script, I don't mean some kind of machine-generated code that's completely unreadable. If you actually look at the script, it's meant to be read by scientists. It's just standard matplotlib code, plus there's some things for accessing the data. You can run the script. You can modify the script, of course. The idea here is, let's say you want to put this in a paper, you want to add a legend, then you can basically do that and get the plot you want for your paper. This is now saving to Plotly, so it saves an HTML page with the plot on the right. And again, I'll just show you what that gives. You can have an interactive figure in an HTML page that you can then either put on your website or in a paper if you want. Some papers are starting to accept interactive figures. There's a plugin package template. If you're interested in distributing a plugin that you developed, we provide a template for that. And at the start of the talk, I mentioned that Glue has a Qt interface, but we've also started working on a Jupyter interface. And if you're using Glue in Jupyter, then of course it's unavoidable that some people on the team will come up with the name Glupiter. Not my favorite, but so it's catchy. Basically, the idea actually is that a lot of the Glue code, it's just Python code, and it's all the way we represent data and links and so on. It's not dependent on the fact that we're using Qt, and so a lot of the code is reusable. So what we've had to do is essentially just develop a new front end for Glue using widgets that can be used in the Jupyter ecosystem. We rely on other widget libraries, so we don't actually develop our own widgets. We have other widget libraries, so we use BQplot and so on, the matplotlib Jupyter widget. And this is, so you can already try it out. It's still at the prototype phase, so we're still, working on making it work properly in Jupyter Lab and so on. But it's already, you can already try it out. So I'll just show you a very quick demo, which is basically using the plain data, but it's just showing 6 hours of the plain data, just to make it easier. So the first thing I'm doing here is just getting the data. Then basically creating the application, which all it is in this case is not going to bring up a GUI. It's just giving you a variable called app, which you can use to then load data. So in this case, you just do app.loadData to get the data. And then we can look at the details of, so this is similar to using the IPython terminal inside Glue, right? So that if you print out the data, you see all the attributes, and then you can start to make visualizations. So this is making a 2D scatter plot. Of the points. It's actually interactive. I'll show in a second. But you can go and change which attributes are being shown and so on. It's very similar to Glue. You can see there's the selection tools and the selection modes for the logic above as well. So this is now showing a histogram of the same data, and because it's Glue, you can go and make selections and then have those selections propagate to other viewers. Interestingly, you'll notice that Jupyter Notebook is not the best UI for this because you have to kind of scroll up and down to see the different viewers. And so this is why we want to make this work properly in Jupyter Lab, and we're very close to getting that working. In Jupyter Lab, you'll then be able to take the views and put them, split them off to the side, and then have basically visualizations, multiple visualizations visible at the same time. Okay, and then at the very bottom, so actually what I've done here is just selected the AND mode, and I can do the same kind of things that I would do in the Qt version of Glue, which is to drill down on specific subsets. And then finally, the last example here is showing a 3D scatter plot. So we use SciPy volume, which can be used. And we also have volume rendering and so on. So we're basically working on first developing the viewers like this, and then we're going to try to make it usable in Jupyter Lab and try to improve the interface, and then maybe make dashboard kind of applications in future. It's compatible with Python 2.7 and 3.5. It's very trendy at this conference to say that you're dropping Python 2, so we will drop Python 2 in the next version. It basically works on Mac, Linux, and Windows, and it's BSD licensed. I just wanted to thank a lot of the projects that we rely on. There's a lot of we use a lot of packages in the Python ecosystem. These are only some of them, so we want to say thank you to those projects. And I'll just leave this up. The main URL for Glue here, the two repositories for the main kind of Glue code and the Jupyter or Jupyter package. And I want to advertise that we have a mailing list and also a Slack team, which you're very welcome to join both of those if you want to get announcements about releases and so on, or if you have questions about using Glue. Thank you very much.
That was great, thank you. So I have a question. You mentioned about being able to make your own linking functions and putting them in a config file. Can I do similar sorts of things with, say, other kinds of helper functions? We had an example earlier where you wanted to show some image data and you click around and assign different colors to different images. If I have that information somewhere in the metadata, can I make my own helper functions and do that way?
Yes, you should be able to. I mean, there's basically worst possible case. There's a kind of generic kind of plugin you can do in Glue, which is called a menu bar plugin, which you can go to that menu bar and execute an action. It will basically. You can go and then color code the data according to certain metadata that's in the data. So all the data objects have a .meta attribute, so you can go and look at that. You can also, I think there's also a kind of plugin. So there's many kinds of plugins. One of them is that when you launch the application and once the data is loaded, some action will happen. So it's like a startup kind of action, and you could do something like that there too.
Thank you for the great presentation. I really like the comprehensive demo videos. I was just wondering, like under the hood, if we're talking about like Glue Jupyter, is there any overlap in like the implementation on the Qt side with Jupyter, or are you guys just starting from scratch?
So actually, we're reusing a lot of the code. So basically, everything to do with representing data, representing links, the data collection, and even things like each different visualization in Glue has a state class, which is not actually dependent on whether it's Qt and so on. It's like a kind of, it's like an abstract representation of the visualization, which says what's on the x-axis, what's on the y-axis, and so on. And we reuse all those classes between the two. So the Jupyter code is actually very short. It's really, all it is we're defining the viewers, and then they just kind of, we need to define how that state class is represented as a Jupyter widget. And yeah, basically that's all we have to do. And so there's a few thousand lines of code, but we're not rewriting everything from scratch. So.
Thank you for the pretty pictures in astrophysics. So my question is, do you retain photometry information when you add all images with different wavelengths for the same bit of the sky together?
Could you say that again? Sorry.
Do you retain photometry information when you add all together from images from different wavelengths of the same patch of the sky? Counts of photons that are generally important for astrophysics.
Okay.
She was asking if you retain photometry information. Did I say that right?
Oh, you mean like, so, sorry, I was just trying to think. So like, so to be able to make kind of, in the reprojection and so on, like you mean, so is it kind of accurate enough to make measurements on the images after? Right, okay, I understand. So so when we do the reprojection, we're basically doing something that's good enough for display, but it's not necessarily accurate enough. That data is not saved anywhere. We do it on the fly, and we just do it for display purposes. And we're just doing essentially interpolation. It's not accurate enough to do detailed photometry on. Yep.
Hi. You mentioned YT a little bit, and I'm using that for visualization. Are you able to volumetrically show visualization in that with YT or anything like that?
So we have, I didn't show it here, we have a volume rendering viewer. So similar to the 3D scatter plot, we can have volume rendering. The way the volume rendering works is that it basically will compute, Glue will ask for a fixed resolution buffer, which is kind of a regular grid at the resolution that you need to show it in the 3D viewer. And when you zoom in and out, it will ask for new buffers. And so what we can do is we can interface with YT and basically ask YT to give us these kind of essentially regridding the data onto a regular grid on the fly. We have a plugin called Glue YT, which basically does exactly that. YT also has utilities for doing actual visualization, so it has like an OpenGL front end essentially. We don't interface with that yet, but that's something we could potentially do in the future.
We have time for one more if anybody has any. All right, I think we have exhausted everyone's questions, so let's give a hand. Good job.